Hi, I'm Aaron McIntyre, Building Science Engineer for the Seed Home. After understanding the thermal envelope and energy flow, we can now pull it all together in the design. As we begin to put lines on paper and your specific design progresses, you can begin to identify the envelope. This is best done with a line drawing on a highlighter. Simply color a line completely around the floors, walls, and ceilings, or the roof, that separate conditioned space from unconditioned space. Once this is done, you can identify problem areas where the thermal insulation may be interrupted or non-continuous. Examples would include intersections of walls, floors, ceilings, or roofs, headers, studs, windows, etc. Any location that your envelope does not have the full R-value planned. Once you understand in detail the makeup of your envelope, you can begin to optimize it by reducing the problem areas. Look to reduce exterior wall intersections, ceiling penetrations, excessive jogs or corners, cantilevered floors, uninsulated headers, and excessive framing materials. You may also want to consider continuous exterior insulation, which is a highly effective way to provide uninterrupted insulation. While you will not eliminate all the problem areas, you can reduce several in the impact on performance. Along with optimizing the insulation, you will need to look at the air leakage potential of the design. Your highlighted outline also represents the location of the air barrier. Determine if this barrier is continuous around the entire structure. Understand where there are direct seams from the interior to the exterior. The easy examples are items like vent pipes and window openings. More subtle examples might include wall corners, wall plates at the foundation and floor, top plates or walls at the ceiling. You need to identify any area that is a potential air leak and then devise a method to seal those areas. Possible methods might include house wraps, adhesives, tapes, foam, etc., and likely will need to be performed at various stages of construction. We should now have a good understanding of what the envelope is and where it is. We have optimized the design by reducing the problem areas in the insulation and framing. We understand the air barrier, location, and have devised sealing methods from slab to attic. Now we need to ensure that these elements are put into practice during construction. Communicate clear requirements to the trades through complete and detailed drawings and design documents. Meet and review the requirements with the trades on site and closely follow progress each step of construction. Many of these concepts and their importance can be new to many trades, and it is important to educate and follow through with the implementation. Lastly, we want to verify what was done. Regarding air infiltration, this can be done with a blower door test. You can see an example later in the tour, but this is a method of depressurizing the home and measuring the air leakage rate of the home. Typically, in new homes, this test is performed at the end. However, the test can be conducted at any point in the envelope is complete. As such, it is often recommended that the test be conducted before the walls are fully covered, which allows for the discovery of unintended air leaks at the point that they can easily be addressed. In summary, we want to design an optimized envelope. We want to ensure the design is properly constructed. Then we want to test to confirm the structure performs the way we have planned.